Imagine you ask an AI a simple question, and it answers instantly. Calm, detailed, completely sure of itself. It hands you a court case with the names, the date, a direct quote, even a citation number. It all looks perfect. There's just one problem. That case doesn't exist. It never happened. The quote was never said. The AI made every bit of it up. And it did it with total confidence in the exact same voice it uses when it's right. Now, our first instinct is to call that lying. But hold on. Lying takes intent. To lie, you have to know the truth and choose to hide it. And a language model doesn't know anything. And it isn't choosing anything. It has no idea it's wrong. It isn't trying to fool you. It's doing exactly what it was built to do. And that, honestly, is the more interesting, slightly unsettling part. This has a name. It's called a hallucination, or more accurately, a confabulation. And over the next few minutes, I want to show you exactly why it happens. The real statistical reason these systems invent things, rooted in how they're built and trained. Because once you see the mechanism, the mystery disappears. And you'll know precisely when to trust one of these tools and when to double check. This isn't a scary video about dangerous AI. It's a video about how a genuinely fascinating machine works. No hype, no doom, just how it works. So let's clear up the biggest misunderstanding first, because everything else follows from it. When you ask an AI a question, it is not looking anything up. Inside a language model, there is no library, no filing cabinet, no neat little database of facts it flips open to find the answer. Here's what it actually does, and it's almost funny how simple it is. It predicts the next word. That's the whole engine. You give it some text, and it asks itself one question. Given everything so far, what word most likely comes next? Then it adds that word and asks again. A whole paragraph, this entire answer is just that one move repeated thousands of times. It is quite literally the world's most sophisticated autocomplete. And notice what it's aiming for. It is not trying to be true. It's trying to be plausible, to produce words that fit, that sound right, that flow like something a person would actually write. Usually what sounds right and what's true are the same thing, which is why it's correct so often. This whole video is about the moments they come apart. My favorite way to picture it is an improv actor. An improv performer has one golden rule: never break the scene. Whatever you hand them, they say yes and keep the story going smoothly, confidently. That is your AI. Ask it anything, and it keeps the scene going with something that fits, whether or not that something is real. So a hallucination isn't the machine breaking, it's the machine doing its completely normal job, generating a plausible next word in a spot where plausible and true parted ways. Okay, but if there's no database inside, where do all the correct facts come from? Because it clearly knows an enormous amount. And this is where it gets beautiful. When the model was trained, it read a huge slice of the internet, and it squeezed all of that down into a fixed set of numbers called weights, billions of them. You can't fit the whole internet into a fixed box without throwing a lot away. So the model doesn't keep the exact words, it keeps the gist, the patterns, the shape of the knowledge. The writer Ted Chiang gave us the perfect phrase for this. He said a chatbot is like a blurry JPEG of the web. You know how a photo saved too small goes soft and smeared? You can still tell what it is, but zoom in and the fine detail is simply gone, and anything filling it back in is a guess. That's exactly how facts sit in here. Common facts, repeated 1,000,000 times online, are stored crisp and sharp, so it recites them perfectly. But rare, obscure, oddly specific ones, A particular date, one small statistic, an exact quote, those are stored blurry or were never really stored at all. And here's the crux, the thing that actually causes the hallucination. When the model reaches one of those blurry spots, it doesn't stop. It can't even tell the spot is blurry. So it does the only thing it knows how to do. It fills the gap with the most plausible sounding detail it can generate. And I want to flip this right around because it's genuinely a wonder. Given that it's compressing a huge chunk of the entire internet into one fixed set of numbers, the miracle isn't that it's sometimes wrong. The miracle is how astonishingly often it's right. Now, here's the part that makes hallucinations so sneaky, and it might be the single most important thing to take away today. The model has no built-in sense of true or false, and it has no sense of I don't know. Think about what you do when someone asks you something you're unsure of. You feel it, that little hesitation, that flicker of doubt. The model has no version of that feeling. Nothing inside it lights up to say this part is solid and this part is a guess. So a made-up answer and a real one roll out of the machine in the exact same way. Same fluent sentences, same calm authority, same confidence. There is no uncertainty phase. If anything, the made-up answers come out even smoother because there's no messy reality holding them back. And that right there is the whole danger. It's not that the AI is wrong sometimes. Everything is wrong sometimes. It's that when it's wrong, it looks and sounds identical to when it's right. You genuinely cannot tell from the tone. Now, researchers at Anthropic actually went inside a model to watch this happen, and what they found is wonderful. There's a kind of default setting in there that leans toward I don't have enough information, a quiet refuse switch, normally on. And there's a competing signal that fires whenever a name or topic looks familiar, which flips that switch off and lets the model answer. Most of the time, that works fine. But sometimes it misfires. A name looks familiar enough to flip the switch, so the model stops holding back, but it doesn't actually have the real details. So instead of saying, I'm not sure, it confidently fills them in. That's a hallucination, caught in the act. No lying, no intent, just a switch that flipped a beat too early. Let's zoom in even closer, right down to how a single word gets chosen, because there's a little chance baked into every one. Remember, at each step, the model is predicting the next word, but it doesn't just pick one answer and commit. It produces a whole spread of options, each with a probability, a percentage chance attached. Maybe one word is very likely, another a bit less likely, and there's a long tail of unlikely words trailing off behind. And then, crucially, it rolls the dice. It samples from that spread. Most of the time it lands on a likely word, but not always. Sometimes it reaches for a less likely one on purpose. There's even a setting that controls how random this is, nicknamed temperature. Turn it down, and the model plays it safe, almost always grabbing the single most likely word. Turn it up, and it wanders, reaches for surprising words, gets more creative. And here's the catch that's easy to miss. The very same randomness that makes an AI a fun, surprising brainstorming partner is the randomness that lets it wander off the facts. It's the same dial. Now, put this together with the blurry JPEG idea, and you can see the whole trap. When you ask about something common, nearly all of the probability piles onto the correct words, so even a random roll lands on the truth. But when you ask about something rare, a spot where the memory is blurry, the correct answer might not be the frontrunner at all. The odds themselves can quietly favor a plausible-sounding wrong word. So the model rolls, lands on something that fits, and hands it to you, beaming. It didn't malfunction. the dice just came up plausible instead of true. We've seen how a hallucination happens. Now the deepest question, the one that ties this whole video together. Why does the model reach for a confident guess instead of just admitting it doesn't know? The answer is a little uncomfortable, because that's what we rewarded it for. There are two stages of training. In the first, the model reads that giant pile of text and learns to predict the next word. It soaks up grammar, style, and the way ideas connect. But here's the key thing. It is never told which sentences are true and which are false. It learns what a correct-sounding answer looks like. And that is not the same as a correct answer. Then comes the second stage, where people and automated tests grade its answers to make it more helpful. And this is where the trap quietly springs. We tend to reward answers that are confident, complete, and helpful, and to mark down a hesitant, "I'm not sure." In 2025, a team of researchers, including a group at OpenAI, laid this out in a paper with a wonderfully blunt title, "Why Language Models Hallucinate." And their picture is perfect. Imagine a multiple choice exam where a wrong answer costs you nothing. A blank scores 0, and a lucky guess might score a point. What's the smart strategy? Always guess. Never leave anything blank. We graded AI models on exactly that kind of test. So rationally, they learn to always answer and never say, "I don't know." In one of their own examples, a model that almost never held back was wrong about 3/4 of the time, while a version tuned to stay quiet when unsure was wrong only about 1/4 of the time, for roughly the same number of correct answers. Guessing tripled the made-up answers, for almost nothing in return. So the model isn't malfunctioning when it bluffs, it's acing the test we accidentally wrote. And how to fix that scoreboard, how to reward honesty without making the model useless, is a live, active area of research right now. Here's the story that made this problem famous, and it's completely real. In 2023, a New York lawyer named Steven Schwartz used an AI chatbot, this one happened to be ChatGPT, to help with legal research. He asked it for past cases that supported his argument, and it gave him a beautiful list. 6 cases with names, dates, quotes, and official-looking citation numbers. So he put them into a brief and filed it in federal court. There was just one problem, and you can probably feel it coming. Not one of those 6 cases existed. The AI had invented all of them. The names, the quotes, the citations, every single piece. And here's the detail that really lands the lesson. At one point, the lawyer got nervous and asked the chatbot directly, "Are these cases real?" And it said yes. It confidently confirmed that its own made-up cases were genuine, a hallucination about its own hallucination. The judge, quite reasonably, was not amused, and the lawyers were fined $5,000. But don't laugh at that lawyer. The mechanism is the entire point. The AI wasn't lying to him. It generated the most plausible-looking legal citations it could. And a plausible-looking citation looks exactly like a real one, minus the small detail of being real. And to be crystal clear, this is not about one chatbot or one company. Every large language model from every lab works this same way. The same mechanism shows up everywhere. Made-up academic references, quotes pinned on people who never said them, confident wrong arithmetic. There's even a sharp-edged version in computer code. And AI sometimes invents a software part that doesn't exist. In one 2025 study, roughly 1 in 5 of the parts it suggested were made up. And attackers noticed and started creating those invented names for real, filling them with harmful code. A word the AI dreamed up becomes an actual trap. Same mechanism every time. A plausible guess delivered with total confidence. So the obvious hope is, won't this just go away as the models get bigger and smarter? And the honest answer is partly, but no, not entirely. Bigger models do hallucinate less on average. More training, more scale generally means fewer made-up answers, but it never drops to zero. And here's the surprising part. Some of the newer so-called reasoning models, the ones built to think in careful steps, actually scored worse on certain fact tests than simpler models before them. I want to handle these numbers gently because this is exactly the kind of thing that changes fast. On one company's own factual test, as of 2025, one newer reasoning model gave a made-up answer roughly a third of the time, about double an earlier model on that same test, and another was wrong close to half the time. And I want to be fair here. Those are that company's own published numbers about their own models, released openly, alongside the words, "more research is needed." That is not a broken company. That's a company being transparent about a hard problem every lab shares. The likely reason is oddly simple. A model that attempts more and says more produces more correct answers and more wrong ones. More claims, more of both. So treat those exact figures as a snapshot. They'll have moved by the time you watch this. But the pattern underneath is the real lesson. Scale is not a full cure. There's one bright spot though, and it points straight at the solution. When you don't ask a model to answer from memory, but instead hand it a document and say, answer using only what's in here, the made-up answers plummet. The best models today invent something only around 1% of the time. And that single fact tells us exactly how to fight back.
So how do we push this back down? There are 4 big levers, and they stack. The first and most powerful we just hinted at. Instead of making the model answer from its blurry memory, you hand it real, trusted documents at the moment you ask and tell it to answer from those, and to point to where it got each fact. It stops reciting from a hazy memory and starts reading from a source. That's the single biggest thing that drives hallucinations down. A whole topic of its own for another day. The second lever is teaching honesty. Remember that exam we graded wrong? You can rescore it. Reward the model for saying, "I don't know," when it truly doesn't, and stop punishing it for holding back. You teach it that an honest silence beats a confident guess. The third lever is giving the model tools. Instead of guessing at a sum, let it use a calculator. Instead of guessing a fact, let it run a real search and read the answer. You turn a guesser into someone who looks things up. And the fourth lever is the one entirely in your hands. And honestly, the most important of all. Treat whatever an AI gives you as a confident first draft, not a final verdict. Ask it for its sources. Check anything that actually matters. Never hand over your judgment on something high stakes. That, in the end, was the lawyer's real mistake. Not using AI, but trusting it without checking. And the honest bottom line, all 4 of these reduce hallucinations, but none of them fully erase it, because it comes from the very heart of how these models work. So it's being managed, not cured. But that's genuinely fine, because now you understand why it happens, which means you know precisely when to lean on it and when to look twice. So let's pull it all together, because this one reframe will change how you use these tools forever. When an AI invents a court case, or a quote, or a fact, it isn't lying and it isn't broken. It's an autocomplete, the most sophisticated one ever built, trained to produce plausible words, storing a huge slice of the internet as a blurry compression, with no sense of its own doubt, rolling gentle dice on every single word, and graded by us to guess boldly rather than admit it's unsure.
When you see all of that at once, the hallucination stops being spooky. It becomes almost obvious. And honestly, the real wonder flips the other way. This thing squeezed a huge chunk of human knowledge into a fixed set of numbers, and it's right an astonishing amount of the time. That is the miracle. The made-up answers are just the price of how the trick is done. So here's the mental model to walk away with. Don't treat an AI like an all-knowing oracle that hands down truth. Treat it like a brilliant, lightning-fast, endlessly confident intern. It can draft, summarize, and explain at superhuman speed, and it hands you all of it with the exact same certainty, whether it's spot on or completely made up. So do what any good boss does with an eager intern. Take the fast, helpful draft, and on anything that matters, check the work. Do that, and these tools go from risky to genuinely wonderfully useful. If this made the machine a little less mysterious, subscribe and stick around. Next time, we're taking another piece of technology you use every day and cracking it wide open, exactly like this. No hype, no doom, just how it works. See you in the next one.